Yeah. Our next speaker is Miss Anusha. She is business intelligence specialist with expertise in semantic modeling, who will talk about semantic models in Microsoft Fabric. Over to you, Anusha.
Thanks, Navya. Hi, everyone. Thanks for joining today's call. So, today, I would like to just start by saying thanks for inviting me as a speaker of Data Analytics Group. Grateful for that. Today's session is designed as a foundational walkthrough, basically a behind the scenes look at how things actually work in Microsoft Fabric and Power BI. Rather than us jumping straight into flashy visuals or advanced reports, we will be focusing on the engine room of your analytics, that is your semantic model. Understanding this layer is critical as it's where your data becomes business logic and where performance is defined and where governance begins. So if you ever asked yourself, why is my report slow, or how can I reuse this logic across teams? Well, this session will connect those dots. Let's start by breaking down the fundamentals that drive everything you see on the front end. Today's agenda will be first of introduction to Microsoft Fabric. Along with this, we'll also be looking at an overview of what Power BI Semantic Model is. Post that, we will be trying to understand the difference between what was there earlier when it was only Power BI and what it is now when we have Fabric. We'll also be walking through on the key components of semantic model along with data access modes, and we'll be taking a deep dive in understanding how the data direct lake mode works, and then we'll have a short demo. So let us start with a small round of introduction on what Microsoft Fabric is really about. Well, it is data. It's basically your all-in-one data platform. Think of it like a super app that brings together everything you need to work with data, whether you're a data engineer or a BI developer, or even just someone who wants to build cool dashboards. So earlier we had separate tools for different things. Like you had Synapse for warehousing, you had Power BI for reporting, you had Data Factory for data pipelines. Each one of this did its own job. So Fabric brings them all under one roof, speaking the same language, sharing the same storage and working together seamlessly. Fabric is also SaaS native, which means you don't need to worry about setting up servers or you don't have to worry about managing clusters, all the patching systems. Just log in, you pick your workload, whether it's data movement or a data science, or say warehousing or reporting, you're good to go. So, well, you can say that Fabric isn't just a tool; it's basically a mind set shift as well. So now this has been Fabric has been in the talk for the last say 1.5 to 2 years almost now, and it's really picking up speed. And a lot of people have started talking about it. So the focus of this and since you know that we are in the AI era, and we want AI to work for us. But then, guys, whenever you look at something, when you want to actually work with AI, you need to have good data because bad data leads to bad AI. So to get good AI, you need good data, and to get that good data, you need a platform where you must do minimal number of tasks with maximum number of outcome, which here is your Microsoft Fabric. So according to my understanding of what I have gathered in my experience with Fabric for more than 1.5 years now, Fabric could be primarily understood by four core functionalities. One that we have discussed just now, which is your SaaS product, where you have everything at one place. Second is your compute. So compute as in all the costing that occurs that comes for your warehousing, your engineering, your data factory, your AI and ML, and your reporting is on all in one place, which is the Fabric capacity. And as you must be familiar with the Fabric capacity, it starts with F2 and F64 is what is usually more talked about as the base for your production workloads in a generalized way. And the third being your one lake. So for anyone who has recently getting to understand or have recently started working on Power BI as well as Microsoft Fabric, the base knowledge that anyone should be having is what is one lake. So one lake is for all of your data. So basically, it's like one drive of data. Why do we call it that? Because see, if you remember, guys, OneDrive is basically a concept where you're going to save all your documents, your Excel sheets, your Power BI reports, and all kind of things that you save there. The same concept is here in Fabric as well. Every kind of data, metadata, whatever is present, you are going to save it in one lake. And then you can create your shortcuts from there. You can also mirror and bring in more data. So the entire foundation that has been created as a single SaaS platform, which is your Fabric, is actually integrated on one lake where all the workloads can read and write from one place with minimal copies of data. So everything that we imagine in Microsoft Fabric is targeted towards this, that you don't have to replicate or duplicate data unless it's absolutely required. Now think about the previous scenarios, before Microsoft Fabric. What used to happen? You used to do all your hard work to create that one gold copy or one gold layer. Let's say that you kept that gold layer in, say, Azure Synapse or some Cosmos DB or some on-premises data warehouse. Then you go to Power BI, and then what do we say? The Power BI works best in the import mode, and then obviously we have composite modes. We have data direct query mode, which we will be going through in this session as well in deeper perspective. But then, as you can understand, we had to hop through many different platforms to finally get that gold layer. But in Microsoft Fabric, what's happening is that these technologies, they know and they understand each other. So, so if I say, for example, that I am saving a structured data in a lake house, the warehouse is able to understand it. And if I say Power BI to fetch the data from a warehouse, the Power BI is able to understand the structure that is behind the structure that is present in those particular warehouses. So by doing this, we are understanding that we are not creating or duplicating the data. Everything is in the same data format file, and each engine, whatever is there inside the Fabric, is able to read, write, and understand it. So the best part of Microsoft Fabric in terms of reporting is that as soon as you have your raw data, as soon as you have your gold layer ready, you are already report ready. Because on top of the goal, we are just directly going to create the models, the measures in the Power BI semantic models, and we're good to go with the reporting. So let's begin an understanding of what exactly semantic models are in the first place, and which part of the architecture that is coming in. Where is it actually situated in our Medellin architecture? So your semantic model is like, let's kick off things, basically by getting a feel of what the Fabric semantic model is and why it's such a big deal in the world of reporting and analytics. But then I have a question. So you might have heard it being called a data set before, right? So when it was in Power BI, it was called a data set, but then semantic model is more a fitting name. First, why has the name been changed? Well, semantic models are just data sets in the Power BI that have been rebranded. So for anyone in this session who have been working on Power BI could understand that it was called a data set before, and now it's being rebranded as yes. Sorry, I got disconnected for a second. Yes. So now it's being rebranded as your semantic model. The Power BI team updated the naming system for two key reasons. First, the term dataset was considered too generic and has different meanings and different contexts. Second, the term semantic model better reflects the functionality of the analysis service data models, which is what Power BI reports are based on. So with the new semantic model view, you have access to underlying components of your model and additional tools like calculation groups, cultures, measures, perspectives, your relationships, roles, and the model tables. Let's move on to the second slide, the other slide of understanding briefly on what a Medellin architecture is. Basically, that is pulling your bringing in your data sources and cleaning it, and finally getting into the warehouse table. So you have your data sources. Through pipelines, we bring it to bronze and then to silver, and then we might maintain some gold data mart layers, post which we have the semantic models. So semantic models, the architecture The when you look at the overall architecture of Fabric, the semantic models place comes after your goal layer in most of the cases, and on top of these semantic models, we build the Power BI reports. So primarily, guys, there are two types of semantic models that are available in Fabric. So one is your default semantic model and one is your custom semantic model. Default semantic model is auto-generated with your Lakehouse or warehouse, which means that when you create your warehouse, for example, the semantic model is automatically created. While the custom semantic model, you will have to manually create it. Let's go into understanding of the default model, semantic model first, and then we move on to your custom semantic model. So in the default one, we do not have much flexibility. It's mostly like read only, and we cannot have much of custom DAGs. We cannot have calculated columns or complex logic. And there's also an issue related. I mean, there's also a concern related to the sync behavior, where we do not have any control on the schema changes in the semantic model, and which might Power BI reports that are built on this default semantic model might also crash because of this sync behavior. So basically, it's like your Power BI report still pointing out to the tables that have already been changed. And then we have the composite model support, that is, which we will be walking through anyway in this session. So I'll just leave that point here. Um, I'd like to end the default semantic model information by saying that it's now being depreciated I think by the month of September, we will no longer be having default semantic models in Fabric. The existing default semantic models that are already in Fabric will be converted to your custom semantic models. So that process has already begun. So for a basic foundation of understanding what a semantic model is, we need to understand what are the types of data access modes that come up in the semantic model. So primarily you have your import mode, direct lake mode, direct query mode, and composite mode. So let's see what happens in your import mode. In the import mode, your data is physically loaded into this semantic model and stored inside the Power BI dataset. Now, this imported data is highly compressed and stored using the VertiPack in-memory engine, which is optimized for the fast columnar analytics. Because of this architecture, import mode offers, a blazingly fast query performance. Users get a high responsive experience, even with complex calculations and also large volumes of data. However, the import mode data is static until it is refreshed. So this introduces the need for scheduled refreshes, which may be carefully managed to balance data freshness with system load. So what happens in that is that in many enterprise environments, this leads to complex refresh planning, incremental strategies, and sometimes latency between the source updates and the report availability. Import mode is also widely used across wide range of source systems, your SQL databases, your Excel, your APIs, and it's a great fit when performance is critical and data freshness can tolerate in some way. I mean, it can tolerate some delay, basically. Now, this is a simple architecture that can give us a easy understanding of what an import mode sounds like. So, the data of this could be your raw data layer and your refined layer, but whatever it is comes into your semantic model where you have the VertiPack file, so VertiPack engine. So basically, whatever data that comes into the Power BI through the import mode, the VertiPack engine is responsible for converting that data into highly compressed and pre-aggregate, and it also gets the aggregations ready. So that means report, your report is very fast. But yeah, of course, as I mentioned, the drawback could be that you will have to set up your incremental loads, and you will also have to set up your refresh settings for refreshing your data in this import mode reports. Now let's walk into understanding of what a direct lake mode is. So this is a big Fabric calls direct lake as a breakthrough technology that it has newly brought in. So let's understand how the architecture is behind the direct lake and why is it what makes direct lakes more special. Here in the direct lake mode, Power BI reads data directly from the delta tables in the one lake. So uh, the fourth pillar of foundation in Fabric is that the data present in Fabric is mostly in delta Parquet format. So usually in the import mode, you could see that I have Power BI reports, I have a semantic model, and then I have a warehouse under it. For example, if it's a Fabric warehouse. Here in the direct lake, what happens is that if the Power BI has to read the data from that particular, say, table, instead of fetching it from the semantic model, it will directly fetch it from the delta tables in the one lake. And this is done without importing or duplicating the data into the semantic model. So that means there is still no data in the semantic model. It directly fetches, goes and fetches the data from the delta tables. This process, this approach basically eliminates the need for refreshes entirely. So data is always live. It's especially powerful in real time and near real time analytics where data latency needs to be minimal. The direct lake requires data to be stored in the delta format, basically your one lake. So this makes an ideal choice when your data pipelines right into your Fabric Lakehouse or data warehouse destinations. Sorry guys, can you hear me? I just got disconnected for a second. Moderator,
Yeah,
can you?
Anusha, you are audible. Yeah, you are audible. Please
Thanks,
continue.
thanks for the confirmation. So what happens is here is that when a user runs a report, the Power BI dynamically transcodes the required column into the vertipack structure on demand right at the query time. So now this process in the direct lake is called transcoding. So transcoding is when the vertipack plays a role only when the query is being called by the report. It doesn't pre-build your aggregations and pre-compress your data. It doesn't do that. It is direct lake mein, what happens is that only when someone tries to read the data or the Power BI report has to fetch the data, it will fetch it through your transcoding technique, that is your delta lake plus a vertipack engine. That is why this direct lake is a very is the best possible mode that Microsoft Fabric is currently providing for your Power BI reports. Here at now that we have discussed about pros of a direct lake mode, let's look at the considerations as well. So the limitations in this is that when you're using a report in your direct lake mode, you cannot have Power Query transformations. You cannot have calculated columns or tables, while calculated columns are, I think, in the pipeline for this financial year. We also cannot have drill through or user defined hierarchies. These are also not available at this point. The third mode that is common in both Power BI and the Microsoft Power Fabric is your direct query mode, basically where there is no storage in the vertipack file and the queries are executed live at runtime against the external database. So if your database, for example, say is an on-premises SQL server, the data will be the report query will be hitting the SQL database and possibly running a SQL select statement in the backend, and then it will be fetching the data into the report. So that means the best advantage of a direct query mode is that you always have latest data because the queries are pushed to the data source here actually. So there is no need for refresh. This also reduces data duplication and storage costs because obviously you're not storing that data anywhere in the report nor in the semantic model. It is still lying in the data source. This particular mode is mostly efficient when you have a real-time reporting where your data sheets they keep frequently changing. So For any frequently changing or near real-time data, you should usually prefer the direct query mode because through this you don't have to separately set up the refresh schedule. Well, let's go to the considerations as well. The limitation, or you say the performance of a direct query report, depends on the source system as well. If the source systems say RAM is very slow and it takes a lot of time to get that query executed, then it will definitely impact your Power BI report performance. You also have many limitations with modeling features, like you cannot have, say, again, your calculated columns because you cannot, I mean, Power BI is not able to create it on the fly. The third would be that we cannot, for high volume queries, it's best to not stress the source systems because uh, the output may be very much delayed, and this will impact your Power BI report performance again. So that means the data for any report that is in the direct query mode, the source, I mean, sorry, the source file the source database should be very optimized, and it should also have a good indexing such that it fetches the data in a very fast and quick way. So that is your direct query mode. So let's get into understanding key when and how should you use these modes. So, for example, if say we have a scenario, say dimensions need frequent ad hoc power query shaping. So that means you will have to keep modifying you have to basically use your power query transformation. For that, you need to go to the recommended mode called import. So this gives you a flexibility in changing and transforming the data. Suppose your scenario is that you have large number of tables, say more than 50 million rows, and this also frequently changes, then the recommended approach is your direct link. Because since it's a large data, importing it and massive re-imports will obviously affect and will give us a good amount of costing. So in order to avoid that, direct link is a suitable approach. Now there could be another scenario where you have dimensional modeling in place, probably a star schema, which has large number of fact tables and very frequently changing dimensions. For that case, you can go for a composite model, which is like a direct link plus input. So what happens here is that your fact tables that are the ones that are large fact tables, they still are connected through direct link. So no data of that fact tables is present in the uh, report. While these dimensions which have been frequently changed, that we consider them as an import mode. So that would require a refresh and a refresh schedule in place. So through this process, you're actually taking advantage of both the modes that are available. Now, there could be a fourth option where the BI team is lacking the Tableau editing skills and they cannot have a slower refresh in place. Then you can go for an import mode. Suppose if someone wants a strict SQL level security and a fallback required, then we will be going for a direct link via the SQL endpoint. So this might leads us to a question called what is fallback. So the fallback. So to understand the fallback, we need to go back to the direct link mode. So what happens is that suppose if a query is not able to fetch the data from the direct link, it will automatically fall to direct query. So what happens is that, for example, say that the data source table might be some shortcut that you have brought or used from some other workspace. So at that, there may be issues ki you might have built a lot of business logic in that particular table. So in that case, the direct link doesn't work. It will directly fall back to your direct query mode. So if your reporting requirement says that whatever happens, let it happen, but I need the report to work smoothly without any issues, then you should go for a direct link which has a fallback capability. So what happens is that even if your direct link mode fails, it switches to your fallback, and you still get the data into the report, although it might be a little more slow. But then there could be another scenario where you are fixed that you still want to go with direct link, then you will not keep the fallback query option. At that time, what happens is that if your direct click fails, then the report visual might also have a chance of failure. So this will affect your end user as well. So you need to make a choice on what kind of scenario, I mean, what kind of recommended mode that you might want to pick up for your use case. So let's have a short demo on understanding how the um, semantic model looks in the workspaces. So I have a test workspace that I've already created. So I have a warehouse that is present here. That is my warehouse. So let's understand how do you create a semantic model in the first place. So I have a set of tables in my warehouse. That is like I have around 3 dimensions and one fact table. So I just have to go to my reporting and click on new semantic model. And I might have to provide this a name and basically select what all tables I want for this particular semantic model. Like let's say like I want all my tables. So let me just go ahead and click select all. It's taking a bit of time because I am working on trial license currently. So you can see that when I went back to the workspace, my session demo semantic model is now created. I can now click on my open semantic model and I can build the relationships here and also create my manage relation. I can also go to manage relationships share. Of course, before I do that, I'll have to change the viewing mode to edit. So in order for someone to have the to able to edit the semantic model, they should have access to they should have the edit rights for that particular semantic model. So the ideal case scenario is key when you're looking at a access perspective. What happens is that if you want your Power BI report developers not to have a right access on the semantic model, the a good approach could be that you maintain the semantic model in in another workspace, and where you will only have where you will only provide view access to the developers. So in that way, in that case, they will not be able to make any changes nor to the semantic model. So then you go ahead, create another workspace where they can actually deploy reports. So there they might have full rights. So when they try to create a report, they will just connect to the semantic model which is lying in another workspace and then create the reports. In this way, you're able to create a bridge. You're able to define the roles and responsibilities of a semantic model developer versus your only Power BI report developer. You can see that at this point of time, whatever changes I am making here goes live. So there's nothing called save or publish. These things don't come in the direct link mode. So for someone who is already working in import mode, what we usually do is that we connect to the data source and we make our report, and when we publish it, then it publishes to the Power BI service. But here, for the semantic model, any changes that you make are instantly reflected. So for example, you let's say in a live scenario, in a production environment, you have a Power BI report which is live, which is hitting the semantic model, and you edit it, you're editing it, making some changes, and by mistake you have removed accidentally deleted 2 to 3 columns. So what happens is that instantly your Power BI report fails. So always be very careful when you're editing your live semantic models. So in order to avoid that, I mean, in order to overcome it, the Fabric is providing something called version history. So that means whenever you are making any changes to this semantic model, you can save it as a version history. So that is like by mistake, if you have done some changes and you want to revert back to the original one, you can always go to the version history and get that thing out. That way you, you can ensure that your semantic model is working smoothly. Now, this semantic model can be accessed in two ways, guys. So one is this particular thing I have done. This is through Power BI service, where I can do all my editing and creation of the model in the Power BI service as well. But then there's also another option to create this semantic model and also to edit the semantic model from Power BI desktop. Let's see how it is. So when you want to open a semantic model which is already present in the Power BI service, you can directly go to Power BI semantic models. But then if you want to create something new, then you go to more, click on Microsoft Fabric, select, say, suppose my destination, my warehouse is present in the Fabric warehouse. I connect there. Now here, if you look here, I have two options that are available. So when the first is connect to one lake. When I'm connecting to one lake, that means I am connecting to my direct lake model. I mean, my semantic model is a direct lake model. So let's see what happens here, just for a brief understanding. So you can see it's connecting with a direct lake warehouse. So Power BI clearly gives you the notification key. Whatever changes you are making in the model will be automatically applied. That is why you don't see the publish option here. Also, if you look at the left hand side of left hand side of my visual, you are not seeing the reporting tab anymore. So that means this is purely your semantic model. Usually in the direct lake mode, these relationships are not auto detected. You will have to create those relationships by yourself. Suppose there are also many several properties, guys, where you can go to your semantic model in the modeling view, look at your properties. You can see that there is an option called direct lake behavior. Here it is not letting me edit this because this has to be first, completely prepared in the service. Once it is already live in Power BI service, I do get an option here. I can uh, I can make this automatic, or I can actually get the fallback behavior also enabled here. So this becomes a very major, a crucial tick mark in your semantic model development. Apart from this, well, you have your tables in which you can use to create your measures, your calculated groups, whatever that has to be created for the semantic model. Now let's go back and create another report and try to understand what happens when you connect to the other option called SQL Server endpoint. I'll go to a blank report again. Microsoft Fabric and my warehouse. Here I am connecting to the SQL Server endpoint, and here it is going to give me two options. One, how do you want to connect it? Either through import mode or a direct query mode. So this is where you can leverage the other two modes of the semantic model, basically your import and your direct query. So when you click on import, it's basically like any regular Power BI report that you've been doing since Power BI was there. So once this is loaded, you can see that the report building and the data options are still available. Like you can go ahead and create your reports directly in this particular file. I hope that is clear to you guys. Let's move on in understanding on how you can actually set up the refresh of the semantic model. On Power BI service, you can go to Power BI refresh settings of the semantic model, and here in the refresh, you can set up two options. Basically, you can keep the best option that Fabric is giving is that you can keep your direct link up to date. That is, when you turn it on, whatever changes that have happened in the one lake, like Mano, like you have your data is being updated at the backend through an ETL, or you have run some update queries. This is immediately reflected in the direct lake tables. So this is a very good advantage. Ki as soon as your tables are ready, your report will automatically reflect the latest data. But then this also comes up with some certain limitations, as in like if your data is frequently changed, then there will be some capacity units that will be dedicatedly working for this, and the costing and the and you might don't you don't maybe you don't want to have that because that is going to consume some capacity units. So you can turn it off if you want. You can also schedule a refresh schedule that you usually do for your import mode Power BI report as well. The other option, the other basic features that Microsoft Power BI, I mean Fabric is currently giving is your Copilot. So this, as of now, can't turn be on because it's not on trial. It's still on trial. But Copilot works from F2 capacity. So once you're on F2 and you can actually take the help of Copilot in building your power in creating, I mean building your Power BI reports. So all your DAX measures can also be created from Copilot in the desktop as well. There is another option called prep data for AI. So what happens is that suppose you want to provide your semantic model for certain business users who can ask the questions by themselves. For example, consider a scenario that you have data from January to December, basically all the 12 months, and your sales are high during the time of, say, May. So what you can prep the AI by saying that if someone asks a question on when are my sales high, you can you I mean when do my sales when are my sales usually high? You can actually prep the data by saying that high sales is equal to my May month. So what happens here is that you're already telling AI what to do and how to answer. So this is one great feature that comes up in semantic model. Let me show you from where you can build this. In the semantic model, there's an option called prep data for AI. Yes, okay, I'm sorry. Since I do not have Copilot, I'm not able to do it. But then again, this is a great option where you can actually tell the AI on what answers have to be given to certain terminologies that will be used in the questions that will be asked by the business user. So this will be a great help for us in the semantic model. So let me go back to the slides. I would like to wrap up this session by this session. Basically, we started with understanding of what Microsoft Fabric is. We talked about the four foundation pillars. That is your all-in-one SaaS, your Delta Analytics, your OneLake. We also covered the Power BI the modes of semantic model, and we kind of went and tried to understand the foundation behind it and how things work at the back end. And the we ended this with a small demo. And the final thought I would want to have as your key takeaway from this session is trying to figure out, I mean, trying to have an understanding of, trying to relate on understanding which mode you have to select and how do you want to build your data platform for your Power BI reporting. Thank you, guys. I hope this session has been helpful for you, and I'm open to any questions. Thanks, Navya. Over to you.
Yeah, thank you, Miss Anusha, for the well structured session. Your take on the semantic modeling was clear and useful. Thank you. Yeah, is there any questions? Please feel free to ask. Yeah, okay. That brings us to the end of the today's session. A big thank you to all our wonderful speakers and to everyone who joined us. We hope we all are living with valuable insights and ideas. See you again in volume 2. Until then, stay curious and keep learning. Have a great day.